Hey, everybody. It is 2 hours UTC, or as you can see, 7 p.m. Mountain Standard Time. That's where I'm located. It also says Sierra Vista, USA. Sierra Vista is in the same county as I am, but not really even close. It takes over an hour to drive there. So I think what I'm going to do with that, that's a site that's called, what is it called? It's called timeanddate.com. So timeanddate.com. And it's a really cool site. It provides a lot of information, provides a little clock there. But I think what I'm going to do, I think there's a way I'm just sort of looking at it here. Oh, you can change my location. Uh, yeah, so because I mean, really, what I want to be able to do is have that be a UTC clock and not a local time clock because local time is eh, it's okay, it's okay, but in truth, there is only one time, and that is now. And right now, it is time for Astronomy Daily Live. This is a live stream done every single day, starting at 2 hours UTC, usually going for about an hour, maybe a little bit more. I do respect your time, so and I also know that you have a lot of choices, and so yeah, I definitely greatly respect your time, and thank you for being here for the amount of time that you are. Come on in, join a circle of friends who share a common passion for astronomy and science in general. Uh, so this is just a casual get together with friends from around the world. Um, this particular time does not really suit those in Europe and Africa, but it does suit pretty much everybody else. So everyone in Eastern Asia, Australia, um, and North and South America. I think this is a pretty decent time. It's impossible to please everybody, and I'm not here to please anybody except me. So I uh, my um, um, evenings here are usually nice and quiet, and I'm sitting here. I'm thinking about um, uh, astronomical things anyway. So why not open it up and see who else shares the same kind of passion? And I think I am filling a niche. There are a lot of astronomical podcasts and things, but they seem to be once or twice a week. Um, Most of the time, they're very topical, where they're it's basically sort of like um, uh, a interview where the host just asks questions of the guest who is some kind of well either doing research or has some kind of knowledge of a topic and yeah, it's not necessarily a conversation, it's more like Q&A. And that is really great. Um, there is room for um, all of that, but to have a daily thing, I haven't seen that anywhere in terms of astronomical stuff. So it's like, hey, let's do it. Let's do it. So got a couple of drinks of choice. I've got I've got the coffee tonight with this awesome mug. These are sort of like, the restaurant mugs that are really thick, and so I've dropped this a couple of times. I don't want to drop it. I don't try to drop it, but I have dropped this mug a few times, on a pretty solid floor, and it's still with me. So this is probably my favorite mug that I've ever had, and I don't even remember where I got it. So that makes it even better because I don't have to thank anybody. It just showed up, and yeah, grateful. So cheers. This has got some of that Kona 10% blend. It also has some Guatemalan um, coffee in it, the kind that you're sort of left, um, or you sort of have access to at the motel room. So yeah. So what I'm going to do, one of the things that I want to start doing is as soon as I go live, I want to tweet that I am going live. So probably what I should do is just create a little thing that I can cut and paste. But for now, I'm going to go astronomy daily. Uh, it's been one of those bad typing days. Daily. Oh man, this is hard with all this stuff in the way. Live is now live streaming. Come join the circle. And then I've got a link to this stream, the YouTube link to this stream. So I will do that. And I'll even put a picture up. Don't know if everybody saw my new sort of logo thing that I put on. I think I put it on my Discord channel. By the way, the link to um, Discord is right down below in the description. All right, so I'm going to do that. Astronomy Daily Live is now live streaming. Come join the circle. And yeah, let's talk astronomy for a while. I think Miss Elite Nugs, hope everything is well. Oh, she's going to be right. She's going to be right back. So yeah, glad you could come in. Hope everything is well. Hope that the garden is doing well. Hope all the ladies are praying and producing exactly what you want. All right, cool. So let's move on. Let's move into the live stream for today. Um, I really sort of scooped the the story yesterday about Proxima Centauri. That's sort of all the news today. So yeah, that's one of the cool things about having a daily live stream is that I can go onto archive.org just maybe 1 or 2 hours after new papers are posted and actually see what is happening before it's actually reported. So yeah, I like it. I like it. Um, one of the one of the things that I did when I was doing a little bit of research in terms of live streaming is that I watch a live stream, and this is actually a shout out to he's cut back a little bit, but Rick Beato, he's got two channels. He's got one that is sort of for produced shows where he goes into musical theory and you know um, does a really in-depth um, um, analysis of uh, of some kind of musical concept. He dives into a song and rips it apart and all that. And then he has a live stream channel too that he was doing daily, but he sort of cut back on that a little bit. Um, uh, yeah, so that's that. But he he's what what I would consider to be a very successful YouTuber. Um, he's got about a quarter of a million subscribers right now, and on his live stream, he usually has between 1 and 200 um, uh, guests that are viewing him at that time. Point this down a little tiny bit. Yeah, that's a little better. So during one of his shows, right before I started mine here, um, he 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 listed sort of uh, four uh, characteristics of a successful YouTuber. Um, Measuring success by how many subscribers, how many new subscribers, sort of is the subscription rate always going up, or is it doing this, that kind of stuff. And then the number of viewers on his live stream. I would like to have 50 to 100 or more come in each day, maybe not even the same ones each day. So if that happens, that'll be really cool. I'm just here to talk astronomy for an hour or so. I'm thinking about astronomy anyway, so I might as well open it up, to the rest of the world. Um, so the four things that can make um, a YouTuber successful, according to Rick Beato, is number one, do outrageous things. That makes for a successful YouTuber. Like do the impossible. Do some crazy shit that gets a lot of attention. Yeah, I'm thinking about that a little bit. Yeah, you know, we'll see. There may be some interesting, outrageous things that I can do in terms of astronomy. We'll see. Um, Number two is inform people on something, and yeah, I think that's what I'm definitely um, I'm trying I'm trying to do, especially new people who are coming in and just they're wanting to learn things astronomical, find out what it's about. Um, so yeah, I think that is pretty much yeah. Um, I can understand that. Number three is he says be interesting to watch. So be interesting to watch, and he sort of gave a few examples, right? Good looking videos, a consistent look, be great on camera, and be very good live. And what he means by very good live is answering questions and being engaging. So, yeah, I think I have a long way to go in terms of that, but I think I can eventually, become pretty interesting to watch. I'm on a learning curve here, folks. I definitely don't want to move into an area where I'm sort of acting, but even this is sort of an act because I definitely do not talk out loud this much, um, unless I'm in a group, right? And I feel as though I am in a group now, and so yeah. But even in a group, I tend to listen a little bit more than talk. I'm just talking now because the group is pretty small, and most of the time relatively quiet. Speaking of quiet, I'm going to go over to that. Hey, there's Susan. Happy Monday. Yeah, everything's good here. Got that covered. Well, okay. Yeah, I don't know if I do or not, but and yeah, I don't necessarily know if it's a gift of Gab. I can certainly talk when I have to, but actually, given the choice, no, I would much rather, sort of do mind melding. So because it takes a lot of energy to gab pretty much constantly for even an hour. So hats off to those who can live stream for 2 or 3 or 4 or 5 or 6 hours at a time. It's like, man. Whew. But over the course of a week, you know if you look at it that way, okay, if one person does a live stream once a week for 6 hours, okay, which is a really long time, right? Well, I'm doing a live stream 7 days a week for a little over an hour. So every week, I'm actually live streaming longer than those folks. So it sort of depends on how you look at it. Uh, so that was number three. That was number three. Is uh, what was it? Be interesting to watch. That was number three. Um, I think consistency is extremely important. Being here at the same time uh, uh, every single day. Um, you know, people start to count on you a little bit. I know the YouTube channels that I watch, that sort of at least want to have sort of a regular thing. Yeah, 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 yeah. And number four, be a great storyteller. So I think in the context of astronomy, I think if I can, talk about astronomy in sort of a neat way, um, uh, and at lots of levels and everything else, I've got some stories for sure, and I think those will come out once we have sort of a larger crowd, because I sort of I mean I'm I'm just like um, um, everyone else, and that is uh, I've I've got to be reminded of um, stories. Trying to come up with one, just sort of um, um, thinking of one, nah, that's not going to happen. But if I get a reminder of some kind of a story, then I can certainly do that. So yeah, yeah. So I'm keeping those kind of 4 points in mind as I move forward with this. I think what I want to do first is take a sip of coffee. Cheers. And reach over here and pull out the dihydrogen oxide. It is dihydrogen oxide tonight, all the way, baby. Yeah. Cheers. couple times a week. A couple times a week, I need the H2O. I just, the HOH just doesn't do it. I need the H2O. So, I go for the dihydrogen oxide. Some people call it dihydrogen monoxide. And I, I'm not a chemist. I'm not a chemist. So I don't know if I'm pronouncing that right. I hope I am. Hopefully, at some point, we'll be able to get somebody with a little bit of knowledge of chemistry in order to sort of uh, unconfuse me about the pronunciation of H2O, whether it should be dihydrogen oxide or dihydrogen monoxide. Um, so yeah, maybe those things are completely wrong. Who knows? Who knows? Who knows? So I think what I'm going to do first is I'm going to do an object of the day, and I'm thinking that I want to go back to the Messier catalog. Now, that's a catalog of 110 non-stellar objects. So these are things that aren't stars. So that would be galaxies, um, um, open clusters, globular clusters, planetary nebulae, and diffuse nebulae. Um, and this was a catalog that was created by a French astronomer named Charles um, um, Messier back in the 1750s, 1760s. I think he was a contemporary of Halley. Pretty sure, and I know that I'm pretty sure that they worked together, and it may even be that Messier sort of turned Halley on to comets. I'm not exactly sure because Messier was a comet hunter, and um, as a comet hunter, what you do is you look at the sky a lot. Okay, a lot. Now imagine being in France, right, in the 1750s. In fact, let me look him up. Let me look him up and see exactly when he was on this planet. Let's see. So I'm going to do Charles Messier, Messier. It's French, so they got to add those little R's onto the end there. So Charles Messier, 1730 to 1817. Yeah. Okay, so that's about right. Um, he was 86 when he died. That's pretty good, pretty good. But yeah, he discovered comets. In fact, at least according to Wikipedia here, he discovered 13 comets uh, from 1760 through 1785. And as a comet hunter, you look at the sky a lot. Okay, every chance you get, you have your scope out and you are looking, right? Looking and looking and looking and looking. And what he discovered while he was looking for comets were these other things that definitely were not stars. They sort of looked like comets, right? They were fuzzy, um, uh, maybe not a lot of color, everything maybe that sort of a comet looks like, except these things didn't move. Okay, comets move because they are going around the sun just like the earth is. And so, relative to the earth, they're always going to be moving. So pretty much every time um, he would observe a comet, he would notice that it had moved. Well, these things didn't move. So they look like comets, but didn't move like comets. So in his mind, he's like, look, what I'm gonna do everybody a favor, right? And I'm gonna write all these down. I'm gonna write down the coordinates, the right ascension and declination of all of these things, whatever they are, okay? And this is a list of stuff that don't bother looking at them. Just don't bother because they're not comets. So who gives a shit, right? Who cares? Well, it turns out that these things were galaxies, clusters, and nebulae um, of different sorts. The reason why he couldn't really distinguish them is because his telescope, um, relatively speaking, was a piece of crap. Right? It was just junk. So what he could see through it just wasn't all that great at all. And again, um, we humans tend to sort of see what we're looking for. So if he was really looking for comets. And so when he saw these things, even an open cluster, okay, even an open cluster, in his mind, he saw a fuzzy thing that was not moving. It's a lot like Percival Lowell, okay? um, Percival Lowell wanted to see canals on Mars. That's what he wanted to see. He had a preconceived idea about what he wanted to see. And so, surprise, surprise, he saw canals on Mars. He mapped them out in extreme detail. He watched them be built, right? He watched the construction of these canals. I mean, he was convinced, that there was a civilization on Mars, maybe in some trouble, because they're having to bring water from the polar caps um, down to the warmer regions. Uh, but nevertheless, he was convinced that he was seeing canals, and Messier was probably the same way. It's like whatever these things are, okay, they're fuzzy looking comets that don't move. I'm going to go back to the chat here so I don't miss anything at all. So, turns out that this catalog ends up being 110 objects. And so, what I'm going to do for the object of the day is we're going to look at one of the Messier objects. So, I'm going to share my screen again. I'm going to go to infinity. I love going to infinity and beyond. And we're going to go over here and we're going to go to random.org. Random.org is awesome because it claims to be the most random number generator. It says random.org offers true random numbers to anyone on the internet. So what you can do is you can set your minimum number and your maximum number. So of course there are 110 Messier objects that go from 1 to 110. So we're going to have random.org choose our object of the day today. And drum roll, please. Bing. M107. M107. Man. Now, I usually think that I know what all the Messier objects are. And M107, dang. I want to say that M107 is a galaxy, but I don't remember. So let's go to our favorite astronomical database. Yeah, yeah. I'd be surprised if it was even 6 inches. He probably, upgraded. He probably had, the fever too. So, maybe he started with something small and uh, um, got some larger ones along the way. But yeah, I mean, a 6 inch reflector. I don't think maybe they were using glass by then, but maybe they were still using metal. So, they would cast it, and yeah, it'd probably be a sphere. So, you'd have just all kinds of um, horrible optical effects that would distort the images and yeah. All right, so let's look at M107 in Simbad. Oh, it's a globular cluster. All right, cool. Globular cluster. So, the other thing that I want to do is, and I'm going to put this microphone down for a second because I want to grab my charts. So hold on one sec. All right, so M107 is a globular cluster, and it has equatorial coordinates of 16 hours, 32 minutes, 31.86 seconds, and negative 13 degrees, 3 minutes, 13.6 seconds declination. So I think what I want to do first is I'm going to go back to, I'm going to stop sharing this screen. I'm going to go back to here, and I pulled out my charts. So what I'm going to do is I'm going to just show you what I'm doing here. So I pulled out the, let me get this so I can see my screen. So I pulled out my Sky Atlas 2000 charts. Bound, it's a bound book of 26 charts that show the entire sky. And these are organized. Is there a chart showing how they're organized? Yeah, and I think I showed this before. Now, these charts are really hard to show on the screen. So I'm just going to sort of plop this up like that. So you can sort of see on the right there, it says 1, 2, 3, and then 4, 5, 6, 7, 8, 9, and then 10, 11, 12, 13, 14. So that follows right ascension. Okay, so number one up there is at the highest declination and also the lowest right ascension. And number two is the same declination range, but the right ascension has moved on. 3 is the same way. And then it goes to the next layer of declination, right? And it starts at 0 hours um, right ascension with number 4 and goes to 24 hours right ascension on number 9. And I know that's really, really, really hard to see. So, but what I'm going to do is I'm going to look at the right ascension and declination of this guy. So he's at 1632 and negative 13. Okay, so negative 13, I know is going to be uh, and these overlap a little bit too. So I think what I want to do is I want to look at maybe chart 14 or chart 15 on here and see what we get. There's 13. I'm going to go back to, I can scoot this over a little bit so I can see. There we go. Okay. So I'm going to look at chart 14 and see where we are. We're at 1632.31. So yeah, I've got to go on to chart number 15 here. And it's going to be really, really low over here. So we're looking at 16. There it is. So 16 hours, 32 minutes, and negative 13 degrees, 3 minutes. So on this chart, this is chart number 15. Ooh, this is going to be hard to show you, but I'm going to try anyway. Oh, this is going to be really hard because I can't even. Here, I've got to switch hands. Hold on. guy. Probably can't hear me very well, but there. I think what I want to try to do, I've been uh, I've been working with Tony Darnell over at deepastronomy.org, and huge shout out to Tony. He's awesome. He's a one man show, and he is kicking ass. He's been doing it for a long, long, long time. He's got a lot of subscribers. He does a excellent, excellent job. He always seems to have technical problems of some sort, which um, I find um, entertaining. So I, you know, I think the only, well, and I can't say this for absolute certainty, of course, but I think it bothers him more than it bothers everybody else. Um, don't mind that at all. Don't mind that at all. We're still playing with this kind of technology, and we're sort of just on the edge of that. So cheers. Yeah, the history of astronomy is awesome. Is awesome. Um, Getting into that, and finding out about how astronomy, the worldwide telescope is just hogging. All right, forget that. Forget world, and it's hogging too much. Hogging too much. All right, I'm back. Yeah. Oh, bummer. Okay. Well, we won't be able to use worldwide telescope. Anyway, I've been working with him on that, and um, Uncle Bill has been kind enough to share a screenshot on my Discord server, which you can find a link to in the description below right now. All right, so I'm going to go back to sharing my screen, and we can look at Simbad, and there's a picture of it there too. So, and I think it's exactly the same. It's probably the Digital Sky survey image. So yeah, okay, so let's go back here. So easy enough to find it on the charts. Let's see. It also has it in galactic coordinates. Now, you remember, we talked about those last night, and you can see that it's 23 degrees above the galactic plane and pretty much in alignment with the center of the galaxy in terms of east and west, or as they say, galactic longitude. Looks like it's moving towards us at a velocity of 33.8 kilometers per second. So yeah, that's still moving pretty fast. 5.4 arc minutes across, and pretty faint, at least in the visual, pretty faint. So ninth or 10th magnitude, that makes it pretty faint. You definitely need, a pretty decent sized scope to see any kind of detail with that. You'll be able to see that, with a good pair of binoculars, but it'll look really small. Pretty hard, to see for sure. So let's see what else we've got about this guy. So here's all of its different names. Everything is an as known as. It's been referenced total of 630 times, and 319 times between 1998 and 2018. That's not too bad. Distance measurements, and then the external archives. Okay, so let's look at the distance, see what the measured distance is. 0.006 million parsecs. So remember, a parsec is 3.26 light years. So then we multiply that by a million. And I'm calculating this with the calculator that I always have at arm's reach. Every good scientist has a calculator, actual physical calculator, within reach at all times. So yeah. All right, so that's that, and then I multiply it by 0.006, and we get 19,560 light years. So if you were to go out and look at this right now, the light that you're seeing from that object started from that object almost 20,000 years ago. So that light's been traveling this entire time. Pretty awesome. Pretty awesome. And see, if you want to find out, and maybe we can do this really quick, like, there's a reference here, and that will probably describe how this distance was measured. So let's just go over there and see. So this is the paper that apparently describes the distance to M107, uniting old stellar systems from globular clusters to giant ellipticals. So we can go down here and go to the ADS reference, the Astrophysics Data System, publisher article, archive ePrint. Okay, let's go to archive ePrint. See what that has to say. Okay, let's look at the PDF file. References are awesome because they allow you just to dive deep. Let's just do a search for M107. See if it comes up here. See, it doesn't come up here. There's another name for M107, right? It's got an NGC number. Let's see if that one comes up. So it's also called NGC 6171. So let's see if 6171 comes up. 71. Oh, NGC 60. So this is really strange to me, right? It's like, okay, we have made a measurement of a distance of almost 20,000 light years away. Here's the reference that is supposed to be talking about that. Yet if I do a search for M107 or NGC 6171, that's the same object, I don't see it anywhere. So WTF? I don't know. How is it that they can say that the distance is measured in this paper when I don't see a reference to that? Talk about some globular clusters, 5128 massive globular clusters. Let's see if it's got another name. Only thing I can think. GLC and C, whatever that is. I don't know. Sometimes these things can be frustrating. It's like, how do you get a distance and reference a paper that claims to make a distance measurement, and then you go to the paper and it's not there? Very frustrating. This is a 16-page long paper, so that's why it's taken so long to get through it. Yeah, man, I don't know. I don't know. Maybe they got to check their references a little bit. Let's go to the picture because everybody likes to see a picture. I like to see a picture. I always start really zoomed in, so I like to zoom way out, get a feel for where we are. So this is a globular cluster. Probably most globular clusters have at least like 100,000 stars in them. So you can see that, right in the middle here, they get so packed in that you have no idea how many are actually there. But you can also see, there's a bunch of them around as well. It's like a hive of bees. They're all gravitationally bound to one another, so they're all zipping around each other. More or less the same age. At least that's the theory. I'm going to zoom out even more here and see what's around the area. And in fact, I'm going to grab my charts, and I'm not going to be able to show you this, but maybe I can. Maybe I can. What did I say? That was chart 15. Because what I want to do is I want to try to give you an idea of the scale here. Yeah, we can do that. We can do that. So look here. Okay. This is star hopping 101. Okay. Do you see this star and this star and this star? These three sort of make a triangle. Okay. And then if you come down here, you see this star and this star. Let me zoom out one more time. Okay. So I'd like to go right in between those two. Let's stick with this one. Okay. So 1, 2, 3. Okay. 1, 2, 3. And then 1, 2 over here. So these three are sort of on this side of M107, and these two are over here, right, on the opposite side. Okay. So now what I'm going to do is I'm going to share my screen, and I'm going to have to put the microphone down, maybe. But I want to show you those three stars on this side and those two stars over here on the other side. So yeah, I'm going to put the microphone down and try to talk into it maybe while I show you this. So okay, bear with me. I still need a mic stand. If I had a mic stand, this would be a done deal. But as it is, low tech. Okay, here I'm going to show you the chart. Ouch, that hurt. Sorry. You see the 3 and the 2? The 3 stars on the one side. Let's see, can I get it in there? I'm on a 7. Oh, where'd it go? There it is. So do you see the 3? The 3 on the one side, you see M107 first, right? That's sort of, I know it's out of focus, but you see the 3 stars over on the one side and the 2 on the other? So that's giving you sort of a sense of scale here, right? So that's a very, very small portion of the sky. Very small portion of the sky that we're looking at here. I'm going to share my screen again. Dun, 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 dun. Like that. Okay, cool. Hide that. But there he is. So yeah, I'm going to zoom out a little bit more. Zoom out a little bit more, see what else is around. Notice there's not a lot of galaxies here. And the reason why there aren't really a lot of galaxies is because, see, you're sort of getting a sense here. See all this, see all these cloudy looking things? There's a lot of dust and gas. And that most likely is thick enough such that we're not really seeing too far past that. So all these stars here, I can say with pretty good certainty are in the foreground, right? So they're between us and these clouds back here. Now, these are clouds in the galaxy itself, so they're way, way, way back. And M107 just so happens to be sort of, on our side of that, so it's still visible. Yeah, so very, very cool. M107 globular cluster. Um, what constellation is that? Let's see. M107 is in the constellation of Ophiuchus. Ophiuchus, and that's uh, sort of right in between Scorpius and Sagittarius. Ophiuchus. I think Ophiuchus is the water. No, that's Aquarius. I don't know who Ophiuchus is in the lore, but let's sort of pan out here a little bit more. See if there's anything else interesting around. There's not much, because this is a very gaseous area of the sky, as you can see. Can I zoom out even more? Yeah, see, so here's here's the galactic equator, right? Here's the disk of the galaxy. Scorpius is down here. You can start to see that. This is the bright star Antares. Here's M8, Messier 8 over here. Sagittarius, can we see Sagittarius yet? Not quite. Not quite. Not in this thing. Anyway, M107 is just sort of lost, lost in there. But yeah, there he is. So let's see. Is there anything else interesting about M107 that we can find out about? It's pretty faint. It's a pretty faint globular cluster. Let's see. Lots of references. Good. We like lots of references. A lot of good information there. MGC 6535, the lowest mass Milky Way globular cluster with a sodium oxygen anti-correlation. I love these big worded titles to papers. Other thing that I just wanted to point out really, really quick, and I will come back to this from time to time, is that I did start a blog many, many, many years ago. It's called Astro and Music at blogspot.com. And I encourage you all to, sort of old. It's a little bit old, needs a little bit of updating, but yeah, post I did last February, and it was sort of some encouraging words from my wife. Right, the size of your audience doesn't always matter. Keep at it. So it's just a cool picture, cute, and yeah, that's exactly how I feel. That's exactly how I feel. But yeah, this blog goes all the way back to 2012. So it goes way, way, way back. Let's look at a couple of the entries that I made. Making a lot of music back then, music experimentation. Let's see if there's anything else. Astronomical music. I was getting into that. showing off my keyboard. Had to make some repairs to it. I still have to make some more repairs to it. Thinking about crowdfunding back in 2020, 2012. I was thinking about crowdfunding before anybody else was. They made it. I didn't. 00 project with images, E2B, a lesson on astronomical magnitudes and colors. That's cool. First look at the data. Okay, I was looking at the Sloan Digital Sky Survey number 3. For some reason, I was looking at color diagrams on that. 6,041 galaxies. So yeah, this is when I was looking for crowdfunding. I'm still looking for crowdfunding, but I think I'm going to do it in a different way now. Lots of info there. Nice rainbow color. Looks like a spectrum. Yeah, this is a spectrum of the sun. That's what the spectrum of the sun looks like. Pretty cool. I'm gonna have to read through all these because I don't know exactly what I was up to. I posted my resume. Wow. Posted my resume on there. That's pretty nice. Anybody want to see my resume? You can see it right there. Did most of my posting, as you can see, the vast majority of it was done in 2014. And I think I was getting into more measuring algal using the multiple mirror sky camera data. So I was getting images like this and looking at the star algal and how it varied in brightness over days. Noisy data. Noisy data. Interesting though. Can probably do much better if I wanted to. I was just messing around. So this is when I got my new webcam that converted into a camera that would go on my scope. It's a Logitech C525. Works well. Works really well. I took the front off and I just glued a uh, a inch and a quarter eyepiece adapter onto it with some Gorilla Glue, and yeah, works really well. That's when I got my cards. And I made a response to an idiot on the internet, not wanting to see something, really bad, and completely misinterpreting what he was seeing. Oh yeah, this is when I discovered that I could grab data about the sun almost live. You know, hours after this data came down from a spacecraft called IRIS. IRIS is an 8-inch telescope that is always looking at the sun, and so all this data is available. And at the time, they wanted to do some kind of special analysis of the data. So I did all of that, and got absolutely no response whatsoever. Went through all this work, all this intense work to identify these peaks and all that stuff, and I got no response at all. It was completely unsatisfying. I created these data products, made them available to anybody who wanted them. I'm just whining. No, it wasn't a T-adapter. It was just I had an eyepiece on hand, and I just sort of unscrewed the part that would go into a telescope, and just glued the other on. Oh yeah, this is when I made my first repair to my keyboard. These little buttons, these are little tiny little things. They're just a couple of millimeters across. And man, I'm still having big problems with these buttons. They are failing like crazy. So this is looking at iris data. This is looking at a system called the Everyscope. Everyscope is awesome. I encourage you all um, um, to look into that project because it's cool. It is very, very cool. Looking at Mars, I found sort of a little spiral in there that was really, really cool looking. Wanting to measure the distance to the moon back in 2014. Well, you know, folks, I am finally doing that. I'm finally doing it. I've got all the data. I've got 3 locations. So yeah, I'm really, really excited, to dive into that and measure the distance to the moon. Doing some artistic garbage crap here. So that was my contributions. Nobody else made a contribution back then. Don't know why. As I said, I've got data now. And look at that. I've got an image of Saturn and a blurry image of Saturn. So this is Saturn in sort of really, really good seeing. This is Saturn in really, really bad seeing. And you see, in the matter of 2 minutes, I mean, I watched this happen. It went from looking pretty good at 5:18 UTC to absolute garbage 2 minutes later. Frustrating, but that's how astronomy goes. So there are the 4 moons of Jupiter as they were seen at 3:09 UTC on the 3rd of May 2014. So here's Jupiter. Here's Jupiter. And then here's its 4 bright Galilean moons. And you can see they're all lined up. They orbit the planet in pretty much the same orbital plane as the Earth does. So you get these alignments all the time like that. Yeah, very cool. I think what I'm going to do is I'm going to exit these waters. I need some food. I need some food in a major, major way. I will get back to this because I hope that this is, moderately interesting. And there's some cool science here. And, this is data that I collected myself, with my scope, my camera, my software, all of it. And it's pretty interesting, cool stuff. But I am feeling the effects of no food and being a human. Unfortunately, I'm gonna have to get some fuel in me before I completely pass out. So yeah, I think I'm going to go for now. Respect your time. Glad you came in for the past hour or so. We're talking astronomy for at least an hour every single day. I'm here every single day. You can count on it. If I'm not going to be here, I will let you know at least um, one day in advance, if not more. But I'm almost always here. I lead a pretty boring life, just thinking astronomy as much as I possibly can. So I'm usually always here. But for now, I'm going to get out, get some food in me, and I will see you again in a little less than 23 hours. All right. Take care. And yep, have a great day. Have a great night. And I will see you again tomorrow for more astronomy, much more. All right, take care. Bye bye.